Okay, so we're going to use basically the same principles to find areas of sectors as we did to find the length of an arc. So our first approach is to use proportions again. I can compare the area of my sector, which let's just remember that a sector is kind of this filled in piece of pie with it's bounded by 2 radii and then this curved arc. So if I compare the amount of sector I have to my total area, that should still be equal or proportional to the central angle compared to the total 360. So we're doing part to whole equals part to whole. So if I were plugging this into my formula, I'm looking for the area, so that's A, compared to my total area, which is pi times r squared, 15.92 squared. That should be the same as my central angle, which I kind of drew over it, so let's see, which is a right angle, so that's 90 degrees. So I should have 90 degrees over 360, and then I just have to solve. So I'm going to multiply by, I want to get A by itself. So I need to eliminate. It's being divided, so the opposite of dividing is multiplying. So I'm going to times both sides by pi times 15.92 squared. Okay, and then it just becomes a calculator problem. So A is about equal to 90 divided by 360 times pi times 15.92 squared, which gives me about 199.1 feet squared. That would be my area. Okay. And now remember, like when we're setting up proportions, as long as we're comparing similar parts, we should still get equivalent fractions. So if I compare the whole number of degrees to the whole number of area, that should equal the part of degrees over the part of area. So I could set this up multiple ways. But our other option is to think about percentages. So again, this is the percent of the circle that my sector is taking up. It's just however much that angle, whatever my angle is, or the arc measure over the total 360. And then I'm going to times that by my area. Remember, the area equals pi r squared. So when I set that up, I know my area is going to be equal to 120, which is the measure of my arc, over 360. That's the percent of the circle that my sector is taking up. And I'm going to times that by the total sector, or the total area of the circle. And that should give me how much area I have. This is just a calculator problem at this point. I just have to type in 120, divide 360, and then multiply that by 100 pi. I did 10 squared to get 100. And that gives me about 104.7 centimeters squared. So you can use either method. You can either set up proportions, set up a proportion, compare part to whole, and then solve. Or you can use this percentage of the circle times the total area and then solve. So pause the video, go ahead and take a minute to try number 1 through 4 on your own, and then come back and check your work. All right, so let's look and see. We're trying to find the area of the sector. So remember, that's this whole like piece of pie. That's what I'm trying to find. So I'm going to use percentage. And I'm going to say that the area has to be, the percent of my circle is 150 out of 360. That's how much I've got. And then I'm going to times that by the area, which is pi times 7 squared. That's just a calculator problem. And I get 64.14, looks like miles was my units, miles squared. Okay, I will use the same method for number 2. I'm going to say that my area is going to be this percent of my circle, 45 out of 360, and then times my total area should be pi times 4 squared. That's just a calculator problem. 45 divided by 360 times 16 pi, which gives me 6.28. And our units are centimeters squared. Right. Those ones are pretty straightforward. You're just plugging in. Remember that no matter what, as we look to these next problems, we know where every variable goes. So I know that my sector area goes in this position. My central angle will be here as part of my percentage, and then my radius is part of that area. So as I look down here at number 3, it says a circle with central angle of 80 degrees creates a sector area of 25.3. So I know I need, this is my central angle. That's my area. I'm trying to find the radius. So this time it's going to be a little trickier because I've got to solve for r. So my area of my sector is equal to the percentage I have of the circle times the total area of the circle. Since we are rounding, I'm just going to take that part. Oops, I circled the wrong part. I'm going to take this part and type it into my calculator. So 80 divided by 360 times pi gives me 0.698. So 25.13 equals 0.698 r squared. Before I can square root both sides, I need to get r all by itself. So I'm going to divide both sides by 0.698. Oops, 25.13 divided by 698. That gives me that 35.9. Actually, let's just make it an even 36 when we round, equals r squared, which is kind of nice because then when I take the square root, I get that the radius is 6. So that means in order to get an area of 25, like there are lots of circles or lots of arcs that would be 80 degrees, but in order to get an area that's 25.13, my radius would have to be 6. Okay, one more example here. This time they tell me that the radius is 7 and that my area is 15.82. I'm trying to solve this time for the angle. So that's where my variable will go. I'll just call my angle x. So I know that the area, which is 15.82, equals the angle, like this is my percentage of the circle. I don't know what that angle is, so I'll just leave it as x. But then I'm going to times it by my total area, which is pi times 7 squared. Okay, I'm going to rewrite this as 15.82 equals x times, I'm just going to kind of rewrite the 360 over here. So 7 squared is 49 pi and then over 360. So in case you're wondering, I just kind of, because this is all being divided by 360, I just moved this over here and put x kind of by itself. That just makes it easier for us to see. That I will put into my calculator. 49 pi divided by 360 gives me 0.427. So 15.82 equals 0.4276x. Divide both sides. 276. So x is going to be equal to, looks like it's about 37. And I didn't have units, so that's my answer. Okay, I'm going to stop this video here. That's skill 2. That is being able to just find the area of a sector or being able to solve for radius or angles if you're given the area of the sector.